Okay, thanks very much for having me here today. Really appreciate it. I'm going to share with you some of my practice essentially as a technology manager. Hopefully some of that kind of resonates with you. Hopefully there'll be some stuff you find sort of useful or interesting. I'm very happy to talk about the stuff at the end. So I've called the talk Metrics, the good, the bad and the ugly, because my experience with metrics is that they are very often presented as being a kind of cure-all or something that is just kind of objectively there and kind of can just be used and is just sort of good in by virtue of being sort of science. And my experience has been quite the opposite. Sometimes it can be very helpful, sometimes it can actually be counterproductive. And the way that you use metrics, the way that you kind of obtain them in the first place, and then what you do, the actions and impacts that come as a result of using them can be, can sometimes be sort of counter effective, or sort of can be against what you're trying to get done. So we'll start off with one of these. Who knows what one of these is? You can raise your hand if you've seen a graph like this before and know what it is. Anyone can tell me? Someone can tell me what one of these is? No. This is a cumulative flow diagram. So this is a way of representing the flow of work through a system. And a graph like this is something I didn't invent that graph, and I didn't come up with it as a way of representing flow, but it's something that I can use and I can share with other people, and it has a meaning. It has a meaning that is actually nothing. It's related to the real world it describes, but it's actually something completely separate. It's an abstraction, and I'm very taken by the book, the Yuval Harari book, *Sapiens*. I don't know if that's available in Portuguese. Has anyone read Yuval Harari's *Sapiens*? I don't know about you, but I found it completely changed just my way of thinking about things. It's something that looks at humanity in such broad scope and comes to the conclusion that actually the things that make us human and the things that make us different from other animals is our ability to make things up and to make stories, and for those stories to have power and to have importance that enables us to do things that we otherwise couldn't. And that's very much what we do with metrics. We tell these stories about the real world, and we use these stories to kind of persuade other people or to inform decisions and to make a difference. And this is the model that I kind of use for working with metrics now. Is that you've got reality, and the metrics are an abstraction from that, and then that abstraction is a sort of feedback loop. It impacts reality. So for this to be of any use, and for this to be something that is not actually damaging to that reality, there are two attributes that we need to pay attention to. There's the quality. So what's the quality of our abstractions when we create these metrics? How well do they relate to that reality? What are they bringing out that's useful, that we can do things with? And then in terms of impact, what value do they have? Because you could have absolutely fantastic data that's telling you in incredible detail about what's happening, but it can be of no real use to actually affect that. So those two aspects, quality and value, are the two things that I'm going to talk about today. They're coincidentally the chapters that I wrote in the book that I co-authored with Mattia Battiston, which we'll come to in the end. So let's talk about quality first. So what do we mean by quality? Has anyone got a definition of quality they'd like to share? Has anyone, if I say what is quality, what would you say it is? Anybody like to, sir, what would you like to say?
Getting value.
Getting value? That's a very good one. We'll come to that later. Anyone else? Anyone got a definition for quality? Sorry? Data quality. That's also a very important dimension of it. I'll take one more. Right at the back.
Meets its purpose.
Sorry? Meets its purpose. Perfect. It's conformance to requirements. So very often when you talk about quality, it already has a kind of an implication that you're talking about high quality. You sort of think about sort of things being gold-plated or being kind of the quality almost being sort of privileged in favour of other things. But really, I think Crosby got this absolutely right in his book, Quality is Free. It's conformance to requirements, which then begs the question, what are the requirements? And I think that definition of quality as conformance to requirements, that's its greatest gift, is it makes you stop and say, well, what are the requirements? What is it we actually need this to do? And you can't really answer that without some awareness of context. So this could be a very, very short talk. I could say, well, if you want to know about quality of metrics, their conformity requirements, context is unique. I don't know any of your context, so we'll finish there. Fortunately, we have some generic models that we can use that help us. And this is really why I'm really flattered and really pleased to be speaking at a DevOps event, because I think this DevOps model is really, really helpful, because to the point the gentleman made at the back about the quality being that it meets the specific, it meets our needs, meets requirements. I've been doing software development for a long time now, about 25 years, and it's only comparatively recently that the operations side has been given the same kind of level of importance as development. You know, development and coding in particular has always been privileged, and you still to this day I find when I'm working with a small team in a startup, the priority will be to hire developers or to hire people writing code, and you raise questions about infrastructure and about sort of operational readiness and that sort of thing, and it always seems to be a sort of a poor cousin. So anything that promotes this model of development and operations as being two things that work together, I'm all for. And also it's a generic model. It's a model you can apply to many contexts. So I'm going to talk about the metrics for quality that I use in development and in operations. So in development, I use the Toyota lean metrics. So these are the metrics that started out from Ono in the production of cars in Japan, and sort of just-in-time production, which have been sort of brought into software development through the work of people like the Poppendieks and through David Anderson. And then on the operations side, I use this IBM RAS model, which I came across. It actually comes from IBM hardware, but I found it a really useful one to apply to operations. So I'll talk about development metrics first. So the three that I use from Toyota are throughput, lead time, and the ratio or the relationship between value and failure demand. Throughput is the rate at which stuff gets delivered, and it's split between, this is a team I'm working with where they're delivering 4 different types of work. They're delivering, this green one is story, so this is stuff that is actually of value to the business. The purple one, tasks, is the sort of operational overhead, so it's like stuff you have to do in order for the system to work, in order to be able to deliver things of value. And then we've got two sorts of bugs. We've got bugs that, it's not really showing up very well in the colour. You've got bugs that are being found in development, so a tester is finding a bug and fixing it, and then you've got bugs that are being found in production, so a customer or a user is finding a bug and it's being fixed. Lead time is for all of these things that are being delivered, so this is cumulative, so over 3 months work gets delivered. Lead time is how long does it take to do an individual piece of work. These two, why I find these two things really useful is not so much for what they tell you, but for the conversations they enable you to have. Because as a technology manager, the question I'm asked the most is, when is this thing going to be done? When is this going to be ready? When can I have this? And by measuring throughput and lead time and being able to present forecasts based on historic throughput and lead time data, you can answer that question and get it out of the way, and then have the more interesting conversations around why are we doing this? What's the value to the business? How should we be dividing our resource between doing different types of work? So it's really to get you out the kind of quagmire of being routinely asked, how long is this thing going to take to do? I'll say one interesting thing about this. This is a histogram of lead time for just the storyline here. So what this tells us is that most of these stories take a very long time to do. They take 60 days, up to somewhere between 30 and 60 days to do, which is, if you were to be working in a kind of rigid sort of sprint pattern of 2 weeks, 2 weeks, 2 weeks, none of this stuff would fit in. So there's two things that that immediately makes me think. One is, why are those things so long? Could they be broken down into smaller things? And two, it reminds me of working on with teams where they are in a rigid 2 week, 2 week, 2 week pattern, where the goal, the measure of throughput actually turned into a target, which is the worst thing that can happen to a measure. It becomes that, oh, on average you're doing 10 stories a week. right, okay, let's try and get 10 stories for the next week. And if the stories themselves are so big they're not going to fit in, all you end up with is quality being sacrificed as stuff gets sort of chopped down and reduced to try and hit that delivery date. But seeing a distribution like this, when I'm then asked by a manager or by a member of the business, how long will something take to deliver, I can say, well, about 50% of the time it's going to take 2 months. A quarter of the time it's going to be 1 week, 2 weeks, and then there's some stuff that will be even longer. But the main thing I'd use this for is for conversations with the people specifying the work and with the developers doing it, to say, okay, how can we either break this down into smaller pieces so that we have more predictable lead time, or can we create some different classes of service so we can say, well, what do we know about this sort of work? Can we look at all of the stuff that ends up in this 2-month bucket and see, does it have any common attributes? So common attributes I see in complex work, things like it has external dependencies. So it might be that the actual time spent on the work is actually, like, say, only a week or 2 weeks, but there's a long time spent waiting for a decision to be made by somebody else, or so on and so forth. Or there might be an investigative part to it. So you can use this kind of lead time data to better understand the work and then better improve your ability to make predictions about throughput. The last one I'll talk about is the difference between value and failure demand. And this is, I think, probably the most important thing to track on the development side, because it's telling you whether your system is producing things of value, or whether it's actually making people's life difficult for them. So this is, again, the same categories that we had on the throughput graph. This is people asking for new things to be built, the green stuff. The purple is new tasks, so this is work that the developers themselves, or the engineers themselves, have said, we need to do this in order to be able to carry on delivering. And then the two types of bugs found during development and bugs found in production. And you can see that there was a period here where the production bugs went up like this and then came down to a kind of fairly even level here. And why this happened, this is why you must always, when you're looking at metrics, you must never look at them in isolation. You must always triangulate them with other ones. It's because this was not that the software that was released had more defects in, is that more people started using the software. So the defects were latent and were being discovered. The increase in the purple tasks here coincided with the start of a piece of R&D work that wasn't necessarily going to deliver anything of value. So the work wasn't classified as being user stories, but was going to have an impact on the business later on. So we've talked about the dev side. I'm now going to talk about the ops side. So there are ops has so many metrics to come out of it. It's because we instrument our systems, and because anything we put into production we can immediately see. We can see logs, we can see information about uptime or about response time and so on and so forth. There's a huge amount of data there. What I like about the RAS model is it splits it into 3 kind of sort of useful categories, 3 things that we can talk about with the business in terms of the requirements. So how reliable do you want this to be? When does it need to be available? Where does it need to be available? And when it breaks, how long can we tolerate it being unavailable before it's back up again? So let's look at 3 examples of that. So reliability. This is just the defects taken from that previous graph. So here we can see, around here, this is pretty erratic. This does not look like a reliable system to me. This looks like something where we don't know how many defects we're going to see. Down here, okay, I'd like this to be 0. I'd really like there to be no defects at all. But at least I can say, okay, it's predictable. We're getting 1 or 2 defects being reported a week. But over here, this does not look reliable to me. And so this is something where, in a conversation with a product owner or a salesperson, if we're trying to decide where do you want to spend your engineering money, do you want to spend it on new features or do you want to spend it on making the system more reliable? Here, I'd be advocating for making the system more reliable. Another way of sort of looking at reliability is to see how many test cases are there. So if there are no test cases being created, and I've worked with software that has no test cases being created for it, it's miserable. You can actually use this to your advantage. You can say, hey, look, here's the correlation between the number of test cases and the number of defects, and you can show how one affects the other. But looking at how much effort is being put into creating test cases is a good indicator of reliability. Availability. So availability is, there are a number of dimensions to availability. It can be, it runs on a single machine, it runs in a single availability zone, it runs 24/7, it only runs during business hours, or it runs up to a certain number of people using it. This is one where we can see when we test it on Blaze Meter with 50 users maximum, you get to a point where errors start to occur, and where what's this? This is response time, isn't it? Response time. Response time increases as the number of users go up. Here's another example of load affecting availability. So the load affecting availability we saw before was where availability drops off if the number of users go up. This is from a video processing pipeline, and this green here is a queue of videos waiting to be processed, building up, because the transcoders have gone offline. So we can use this as an indication of both. We can tell we've got a problem with availability if something goes wrong, but we can also tell from that metric if our queue length is going out of a certain bound, we know we've got an availability problem, and we need to get in and investigate it. And the final one on availability, I use this, well, I work for a company called Honeycomb, which is what this t-shirt is from. I was the CTO for 3 years, and I went through the Series A round with that company. And this diagram was in our investor deck because it was our way of saying that this graph shows queues and work in progress on transcoders. So this was transcoders running in the cloud, and we had to run a Windows transcoder in the cloud because the particular transcoder we were using was mandated by UK broadcasters. So we were on Windows boxes, virtual Windows boxes. But we showed this bit here as being, this is when it's not used, so this is when we switch them off. And when we did the investor pitch, the finance people in the investor pitch, always their eyes lit up, where it's like, was that you can tell when you don't need your infrastructure? It's fantastic. So availability is, you don't necessarily need availability all the time. So if you know when things need to be available, and they're things that are switch on and offable, then your availability metrics help you do that. Finally, serviceability. So in that example just there, I could not have fixed that problem because I've never seen this laptop before, and I don't know how the AV works. So for there, we need to have somebody with the domain knowledge to be able to fix that. And similarly, if you've got a platform, so here we've got a platform we split into 4 different parts. Who can fix it when it goes wrong? So for these 3, input, output, and admin, we've got a pretty good mix of people here who can work on this by themselves if needed. Or we go down through, they know the code, but they would need someone to work with them on it, through to they know the tech, so maybe they know Java, but they don't know anything about the problem domain. 2, they don't know either, but they'd like to learn on it. And finally, please don't ask me to do anything with this because it's really not my bag. And we can see, so here, Robert in India, and I've included the geographic thing here because if you're working on a system that's available around the world, you need to know, when are people available to fix things? Is it going to be a PagerDuty thing, or is it someone's office hours? So here we can see we have good coverage here, not so good coverage on here. So this search part, the serviceability of this is going to be low because there's only one person who can actually work with it on their own, and everyone else has scored a 4 or a 3 on that. Okay, so I'm going to try and bring those metrics together to tell you a real story about something that really happened, and hopefully see this is not just me kind of making stuff up. So once upon a time, there was a SaaS platform, and that SaaS platform had 4 services: admin, input, output, and search. Search had problems. Search had been outsourced to somebody else to build, and then was then given back to the in-house engineering team and said, here you are, look after this please, this is now your responsibility. And then a business decision needed to be made. sales wanted more features added into search. They were going after particular leads, and they said, this search feature, this search part of the platform, it needs these extra features in it. Engineering, basically me, was saying, no, we need to fix the problems that we've inherited. And we need to be putting our resources into that. And it was a kind of like a standoff, really. It was a standoff based on either who shouts loudest or whose opinion outweighs the other. So the way I looked at addressing this was to bring in some data and use data to tell the story rather than it just being my opinion of this thing sucks and I want to fix it. So to make the case, we started with operational metrics. So the first thing I did was draw a radar diagram of the functionality as it related to the three RAS dimensions of reliability, and availability and serviceability. I find these radar diagrams really helpful for calling out the multi-dimensional nature of quality and value and of requirements. So when you have kind of different people asking for different things, you can visualize that and say, well, at the moment we're privileging this over these other things. And you can kind of use that to sort of show where things might be sort of not quite fit for purpose. This use of radar diagrams in this way is from David Anderson. So for reliability, I use the data around defect discovery. So of those four systems, only one of them, the search system, was raising what we call showstopper defects. A showstopper defect was something where a salesperson was ringing engineering on the day of a demo to a client to say, I can't get my demo to work. So this line going up is showing, we've got problems here that we can jump on them and herd around them and fix them on the day, or we can just do the work to make sure they don't appear in the first place. The next one was availability. So if you remember that graph we had for the queue lengths around transcoding, this is similar. This is search latency going up. So in October it was about 2 seconds. By December it was 10 seconds. So clearly something is going wrong here. Something is happening with the system over that time. The third one was serviceability. So this is exactly the same graph I showed before, but the search system, there was only one person who knew how the search system worked because we'd inherited it from a third party. The rest of the platform was written in Java, this was written in C#. It was just, we would need to make investment in addressing this liquidity imbalance. So those were the operational metrics that I used to make the case. For the development metrics, it was far more about predictability and forecasting that we could manage the delivery of this in a predictable way. So this is I copied and pasted this from the white paper that I had to put together to explain why we wanted to do this piece of work. And really this was all about providing a predictable level of throughput based on historic data. So how did the story end? I'd really like to be able to tell you that it was a fantastic success and we delivered exactly on time according to our throughput metrics. Because this is what we should have seen. We should have seen throughput going like this. What we actually got was this. And it's kind of bittersweet because yes, we did actually deliver to our prediction. But I don't need to tell a crowd of DevOps people what's wrong with this. What's wrong with this is revealed by the cumulative flow diagram. So the cumulative flow diagram, I find they're so useful. I find when you first show them to people, they're kind of like, my eyes, well, what is this? But once you dig into them, they can be really useful. And this is showing the flow of that work on that graph from its original state of being either open or in a backlog. This is actually the same state. So I need to do some Jira housekeeping. I won't bore you with that. Going into a queue to do next, being in progress. So the development team did a really good job of limiting WIP in progress here, but then things start to go wrong. So there's a queue that starts backing up around QA, then putting it into a queue for deployment, and deployment doesn't happen till here. So what you're seeing there is the late availability of infrastructure, so the delaying of risk until the last point. So what this meant was the story that I wanted to be able to tell to the executive, to the rest of the business, about how we had successfully done this work to make this change, and here we are, and here's our predictable throughput. That instead it turned into a sort of retrospective story with the engineering team to say, this is a level of risk that we're introducing, and this is something that we don't want to do again. So it's, as I say, so it's bittersweet. We replaced the inherited part of the system. The defect rate has gone down. Customer satisfaction has gone up. All that sort of thing. But it's with anything like this, if you've got a less than positive situation, if you can use it as a way of improving and a way of learning, then all for it. So there's a lot of data here. I've presented it to you as if it's kind of gospel, and I want to just talk a little bit about how you what you need to do when people start showing you numbers and you kind of wonder, well, where did that come from? So underneath the sort of model of dev and ops, it's really important to look at the metrics practice itself. I'm just going to talk about a couple of things. Data cleanliness is the one that I come back to again and again. I don't know if anyone knows Bruce Sterling. He's a big kind of person in the kind of enclosure and kind of big data and that. And he says, if you don't think you've got a data quality problem, you haven't looked at your data. And I find this so true. Whenever you're trying to do any data processing and you run data into something and suddenly it trips up and it's like, oh, why is that? Oh, the naming convention hasn't been honoured here. Or, oh right, okay, we didn't allow for this case. I'll show you a couple of examples. So here's throughput through the system, and throughput suddenly goes up here. It's like, wow, what happened there? Does anyone want to suggest what happened to throughput in the diagram here? Why did it suddenly go up?
You finally deployed.
Sorry?
You finally deployed?
It could have been. Based on the previous diagram, you'd think, yeah, that would be it. This is the thing. This team actually had a really good practice of getting stuff into production. But for that new system, they left the provisioning and deployment of the new infrastructure till really late. And I was kind of tearing my hair, well, what's left of my hair out, thinking, well, why are we not doing this? Why, we've got good practice over here. Why have we not applied it over here? But it wasn't that. Anyone else? I'll tell you what it was. Somebody had gone through and decided to do a cleanup of Jira. And move a whole load of tickets that were kind of like, oh, we're not working on these anymore, move them to done. So it suddenly looks in Jira as if this stuff's all done. So what we've done instead is we've created a stakeholder inactive and moved them to there. Now I know in Jira you can have when things are moved to done, you can say wasn't done or what have you. But when you add extra complexity into the way reporting gets captured, my experience is that stuff goes out the window. It's just what's in the done state. Oh, this is all done. All right. So the next one is selection. So it's kind of choosing what not to show. So this diagram I showed you before, we have these two different types of defects. When I show this to the executive, I remove the development bugs. And the reason I remove the development bugs is because I was getting the question of, why have we got so many development bugs? Why? What can our developers not write code? What's going on there? And I was, this was sort of causing me some kind of consternation, because I was thinking, is this something where we have a quality problem and we should be stopping these defects from occurring, or do we actually have a QA team or testers that are doing their job? And I was looking through the Lisa Crispin Agile Testing book, and I found this chapter on how metrics can be either a motivating or a demotivating force. And she says here, an increased number of defect reports might mean the team is doing a better job of testing, not that they're writing more buggy code. And so that was something where I kind of, based on the response I got from the management team, I presented this rather than that. Now actually when I did the rehearsal for this talk over Zoom, one of the bits of feedback I got was that actually this is a better story with this data included, because it shows that you're kind of left shifting the quality and you're finding stuff before it gets released. So I might come back and revise that story afterwards, but the takeaway from this is when somebody shows you a graph like this, it's worth thinking, what have they taken out? What's being removed from here to sort of affect the story that's being told? So with that's quality, the quality side of the equation, we're now going to talk about the value side. So quality abstracts from reality. So it kind of informs the stories that you tell and sort of predicates the decisions you make. Value impacts reality, and that's where stuff really gets real, because you can start really kind of upsetting people or damaging things or doing all kinds of, making all sorts of mess if the value of your metrics is not really being sort of thought about. So we've got this generic model. on top of that, we want to look at business value. We want to say, okay, so we know how to, so we've instrumented and can see the metrics for development and for operations. We're conscious of the issues of cleanliness, bias and selection in our metrics practice. What about business value? You said it before. Somebody at the front said about quality being value. Was it you? Yeah. So value is value and quality. That it's as much conformance to requirements. It's going back to why and saying, well, why are we doing this? What is the value behind this? What makes it difficult is that is whereas these are, you know, we can be sort of generic about them. This is always sort of context specific. So it's more difficult to talk about business value without understanding the domain. Fortunately, there are some really good cross-domain models that you can use as well. My favourite one is the Dave McClure Pirate Metrics. Has anyone heard of that before? Dave McClure's Pirate Metrics. It's great if just because of the name. It's R, like pirates say. So, this is what it is. There's a link to the full video. There's a fantastic video of him talking about it, which I urge you all to go and see. The metrics are acquisition, so it's find your customers, activation, actually get them onto the platform and using the platform. There's retention, so do they stick around and carry on using the platform, and referral, do they tell other people about it, so do you get other customers from that? And critically, does any revenue come out the bottom? So you can look at the metrics around these 5 things and see how they're working. So I'll tell you another story. The first story was a kind of a sort of bittersweet reflection on how metrics needed to be used to make an internal business decision. This is a story about how metrics were used to both qualify a piece of work and then to aid its delivery. So it was from a few years ago now. It was when I was working for a digital agency, and it was for Nuffield Health, who are a big chain of gyms and hospitals in the United Kingdom. So let's talk about the business need first. So they wanted us to help them with acquisition. So they had a website where TV adverts and web adverts would link to this, and sorry, I've just remembered that one of the things I was going to show is on that laptop and not on this one. So don't worry about it. We'll sort it out. So acquisition of customers. Then we wanted to activate and turn them into actual gym users by providing a mechanism at the gym where they could take the pass they generated online, turn it into a one day at the gym. And then they wanted to see higher revenue coming out through people staying and staying on as gym members, and ideally telling their friends about it and getting the referral. So as a provider of software, our responsibility was kind of the acquisition and activation. Once people were into the system, it was really up to the customer itself to deal with retention and referral. But if we didn't get people in, that was never going to really happen. So we had a business need. We had a qualified business need, which was around this increasing of revenue, so we could measure whether anything was worthwhile was happening there. What about development? So here we use the metrics. We use the lean metrics to figure out whether we're going to be able to get this thing done in time. So this was launching in what the fitness world calls the golden quarter. The golden quarter is the first 3 months of the year, because everyone comes back from their Christmas holiday and they're like, oh, I've had too much to eat, drunk too much, right, I need to go to the gym. So that's when you hit them with the adverts to say, come and get a free gym pass. So we had to know that this could be delivered in time. Otherwise, if it was delivered a day late, it would be worth nothing, because the TV ads were being made, the TV spend was the slots were being booked. This had to be in place. So we story mapped it. We provided a level of complexity in the story maps. From that, we inferred lead time, and we're then able to figure out throughput. So this was the forecast throughput here. This red line here is the actual throughput. So we actually did better than the estimate, which was great. We delivered more stuff on time, and then we carried on delivering stuff. So in that way, it was a great vindication of using lead time and throughput as a way of delivering stuff. The operational metrics, the key one for me was how many tests are there. So we had a really strong test practice. So this is at the acceptance level. So we had at the unit level, it was a Ruby application. So we had RSpec doing all the tests at the unit level, and then Cucumber for the tests up here. This is where I was going to flip to Excel. So this is just the Apache logs telling us the referrer URL for the website. So this was enough for us to be able to tell which ads were working and which ones weren't. So that was an immediate drive. I could go straight back to the customer and say, all right, most of them are coming from these Google search terms. From these Google search terms, we're getting nothing. Right, let's structure our investment around there. And it was a way of kind of, for me, it sort of shows how important the instrumentation is, because both from an operational point of view, but then if you can plug that straight back into business value and say, look, this stuff is beneficial to you, then it's great. So the output of all of this, the upshot of this, was that we succeeded on the acquisition and activation part. We achieved the goal of higher revenue for the customer, and the evidence of us achieving that higher goal for the customer was twofold. One was they reported it back to us and said, look, the subscription rates are going up, this is working. But even better, for us as an agency, they said, could you do something similar for our physiotherapists? And we said, yeah, we can. And we said, and we can do it in about a quarter of the time, because we can reuse most of what we built here. So we got repeat business. So it was a double win. So it's fantastic. So that's a story with a happy ending. That's the sort of the model altogether. So DevOps with the Toyota metrics and the IBM RAS metrics, paying attention to the metrics practice, the pirate metrics model for business for the business need. And I'll come back to where I started with the Yuval Harari quote about the fact that we create these imaginary things that only exist in stories that we invent. Because yes, they are powerful, but they've always got to be questioned. You've always got to look at them and say, what am I not being told? And or what is this predicated on? And the absolute best quote I've seen that sums this up for me comes from Margaret Atwood. So I'm going to finish with this Margaret Atwood quote here. She says, there's the story, then there's the real story, then there's the story of how the story came to be told, and then there's what you leave out of the story, which is part of the story too. And it's for me, it's reminding us to always be kind of sort of prodding and pushing at anything that's presented to us as fact or as kind of evidence, and sort of problematize that and kind of inspect it and sort of have a sort of dialogue with that. What you've just heard now is really a kind of massive distillation of my 2 chapters in the Metrics of Business Decisions book, co-authored by the wonderful and incredibly patient Mattia Battiston. And with that, and there's a discount you can go. If you go to this URL, you get a 15% discount of it. So that just leaves me to say thank you very much, and I'm happy to take any questions. Do we have a mic for questions? Do we have any questions? Yes.
How common is it that your metrics become goals? Because you said it was a temptation and it was something very bad to happen.
So the question was, how often do the metrics become goals? So I am very much of the belief that as soon as the metric becomes a goal, it loses its value as a metric, because it just starts to affect behaviour. And we are so clever as human beings that we will immediately game the system. Sometimes that gaming the system is actually good. And that the one time that the gaming the system I find good is go all the way back to, when was it? That was right at the beginning. This one. So here, when you have massive variation in lead time, it's really hard to do predictable throughput. So if you can make the case for reducing lead time and working with smaller batch sizes, then as a result you get more predictable throughput and it becomes much easier to have those conversations. But I would present the goal as being smaller less complicated, less interdependent pieces of work, and make the case for the values of those rather than presenting the goal as being reduce lead time to X, because it may well be that the very nature of the work means that that's impossible, or you may start working on other things that nullify that. So I'm very careful with it's a really good question, and it's a really difficult one, because you'll often hear goals talked about as being qualified by a number to make them attainable. So yes, a goal should be measurable. So you may say like a goal of a sort of 20% increase in revenue, but if you think you're able to actually infer every single variable or dependency that's created that increase in revenue, you're a better person than I am. So I think it's important to make a distinction between a qualified outcome and the sort of the range of measurable behaviours or things that have reached that. So I'd say nine times out of 10, I'd say never, unless there are actual reasons you have for wanting to drive behaviour in a particular way. And anything you're doing to try and drive behaviour in a particular way, it's a far more complex engagement with your fellow human beings to do it. So it's very much proceed with caution, your mileage may vary. Does that answer the question? Cool. Any other questions?
Do you have any way to get those metrics from inside the code and not outside of the code?
So the question was, do you have any way of getting the metrics from inside the code and not outside the code? Were there any metrics in particular you were thinking of there, or?
Basically, when you put the ops mode.
Oh yeah. Which?
When you divide it by the 4 domains.
Oh, okay. Yeah. Let me go to.
Over there.
Here.
Yeah, and in the previous one, that one, those 4 domains. So
here.
Yeah. So do you have any metrics that comes from inside, so you can see inside domain admin or input output what's going on, what's getting bad?
Yes. So particularly on the search term latency increasing, that was straight from there. That was the metrics on the.
It was written by outside, right? That was not the time for each block.
Okay, so yeah, that was us putting instrumentation in place to say, okay, from the user's perspective, we can see this is a problem. Let's now instrument and see that that's going on there. So everything here is instrumented. So the where's it gone? No, it was previously, was that, wasn't it? Where's the, here. So being able to do this instrumentation here, you need to have, you need to make any sense of this, we have logs that say, so we can say what the average response time for an API call is. We try and think so things like here, so for generating queue lengths, again, this is events being logged to this was reported into Grafana. We're using log entries. So this is stuff going into log entries and to can't think what the other tool was, but yes, this is all generated by instrumentation that says what's the current queue length, how many jobs are currently in progress. So there, it's very much driven by the code. So one thing I'm sort of really keen on is having consistent logging, and within your logging having correlation IDs, so that if you've got something that touches a number of systems, they all use the same ID. So you can do things like you can trace the end-to-end cycle time on things. So I'd say anything, wherever possible, you want the metrics to be self-generating. So it absolutely wants to be coming from inside the code, because applying it retrospectively is really, really hard. And if you're having to do things like if you're having to pick through logs by hand to figure out whether how often something is failing, then you're making life very hard for yourself. There are some things where we have to look after the event. So I think things like number of defects recorded, that was just going into Jira and pulling out a report of when people logged errors. So where we can, we did. Where we couldn't, we had to do it after the event. I don't know. Does that answer the question? Okay. Do we have time for any more questions? The man at the back with the t-shirt. Sorry, he's pointing to someone else. 303. Sorry, sir.
You kind of suggested lead time for the dev teams, but sometimes I see lead time to including the ops teams also.
So the question was, or the observation was, that I just used lead time on the dev side, but not on the ops side. That's a very good point, and I think the difference between the way I've modelled things here is on the dev side I've used 3 specific metrics, whereas on the ops side I've used 3 kind of categories, because I think on the ops side you have a plethora of data, and you have a much better habit of creating data. So try and find the example from ops of where I think that this lead time is useful on the ops side is on serviceability. So it's how long does it take to resolve something, and so that can be done by, again, ideally if the software can log I've failed, and then you've got a way of people working on fixing things to be able to either log at what point did they know about it, and then you're able to log at what point the system was brought back up again. Then that's something where you can look at lead time and say, okay, does for this category of event, how long generally are we able to get back up and running again? And then you can see if there's an exception. So if the system is down for much longer than another, you can say, well, let's dig into that and see why that might be. That's one example I'd see of lead time. I guess another might be, I suppose it depends where you draw your DevOps boundary. If it's, if you're aiming for sort of 0 downtime deploys and you have some, and you don't have that, for example, you might look at that and say, okay, well, is that something we can measure? Are there particular things where, say, data migrations are required that means it's longer, or what have you? So, yeah, I think there are useful cases for it. I would say the reason I like that RAS model is you can step back and say, well, how is this helping us understand the kind of quality of our system? Is it in terms of reliability, availability, or serviceability? And it's those itties are not the only ones. You can add in as many as you like, and you can add in ones from your domain. I guess what I'm trying to do there is just encourage. No, it was back there, wasn't it? Encourage thinking about the system multidimensionally. Lisa Perry has called her new book Escaping the Build Trap, and it's very much, this is what I see as the build trap, is where you're just relentlessly, well, let's add another feature, add another feature, add another feature, and you're not thinking about these other aspects of it. And it's really why I think the DevOps relationship is so important, and why it's attending to all this stuff that is kind of so often is like, oh well, yeah, anyway, somebody else can think about that, and don't worry about that. It's all serverless now anyway, so we don't need to think about it. And we privilege the sort of development over the other things. So I would say yes, it's a useful thing to use in the right context with the right kind of intention. Does that answer the question?
Yes.
Cool. Do we have time for any more questions? Do we have any questions, sir?
Everyone wants metrics, but the majority of the companies are not willing to invest to have that metrics practice that you spoke. How do you make the push inside the organizations that you work? How do you decide how much people will work on that metrics area? It's just you, or you push it? But my experience is when you are working, that part of cleaning the data, preparing, presenting is a lot of work, and the majority of the organizations drop off when they see the amount of work that they have to do to have that visibility. In your experience, what is the best way to approach this, to implement this metrics practice?
So that's a fantastic question. I'll paraphrase and repeat here. So the gentleman was saying that let me go back to the right bit of the diagram. Where did we have it? No, sorry, bear with me a second while I find the right slide. So this metrics practice, so ensuring that the metrics you use in development and in operations is clean and fit for purpose, there's a lot of work in doing that. And if in an organisation where the organisation can't see the value of that and doesn't want people spending time on that, how do you make the case for spending time on that? Is that a fair assessment?
Can you also divide it by the stage of the startup or the business when you answer that question?
Yeah, gosh, that's a good angle on it. So the first thing I'd say is that you need to show the value of working with clean data. So you can show some examples of where a lack of cleanliness in the data makes the data worse than useless. So that's why I include that example of the spike going up here. And so if you have if you don't kind of select your data correctly or don't present it correctly, and then it's so what I've done in the past is where somebody said, why are you spending all this time cleaning the data, is I present a graph with a erroneous aspect to it, something wrong in it, and say, okay, based on that, what would you say this is the health of the system is, or what would you say the state of the system is, or where would you make your next investment? So an example I've got is the speed at which I worked for a business where we were sending a lot of large video files around, and we had a real bottleneck on one part of the system. So I wanted to invest in fixing that bottleneck. I've had metrics that don't show that bottleneck there and just show, just show. So say they're only reporting from the point where files are started to be uploaded to an FTP site rather than when the thing is completed. If that data was wrong, it wouldn't show the bottleneck and it wouldn't show there was a problem that needed to be resolved. So I guess what I'm trying to say is, if you can present some examples of where that lack of cleanliness will actually result in really bad decisions made by the business, then that's a way that I've used in the past to kind of say, look, we have to get this right. And critically for startups, I think, because at startups you're making bets really, and you're looking at ways of informing those bets. So again, go back to the file sending example. We had to make a decision between, do we invest in adding more broadcasters in the UK, or do we invest in adding a new country? So do we go and invest in connecting German broadcasters? And for that we needed to look at the cost of doing so. So in the UK we knew that they were all either using FTP or Signiant or Aspera, and we go to Germany and we find, they're now using another file transfer mechanism that we've not seen before. Right, okay, what's the cost of doing that? Okay, so we have to really make sure that our metrics for throughput and cycle time lead time rather, are correct. Otherwise we're giving a bad steer to the business. So it's almost a sort of inverse spec by example. It's like, here are examples of what happens if you don't have this cleanliness here. If that doesn't work, what I always do with software development teams is I say we must reserve a certain amount of our capacity for ourselves, and I just am really kind of forceful with the rest of the business about that, and say we have to reserve, say 25% is for working on engineering itself. Otherwise it's a bit like driving a car and only spending money on petrol and not spending money on replacing the brake pads or checking the oil or anything like that. It's just like, yeah, you don't have to do that, and you can probably go a few more miles, but sooner or later the car's going to come off the road, or you're going to be stopped and you're going to fail your Ministry of Transport test or whatever because you're not attending to those things. So it's forcing the whole business, including engineering, to think about the thing multidimensionally and say, where are we putting our money, and to just be kind of quite sort of forceful about reserving money on data to spend on data cleanliness. Those are my two approaches that I've used. Does that answer the question? Cool.
Okay, so thank you, Chris.
Thank you.